Hi, this is part 1 of section 5.7 dealing with trig inverse integral. There's two formulas we have to go over. You can pause them, copy them down. Now the important thing here to note is that the a is going to be considered a constant, and then a u is going to be considered a variable. And it's not going to necessarily be a u substitution, it's just the way the formula is written. And the way I memorized these was the fact that you're taking a constant squared minus a variable squared, and there's no other variable in the integral, just the du is in the numerator, and it's the square root obviously, so it's going to be the arcsine of u over a. And then for the arctangent, it's a constant squared plus a variable squared with no other variable in the problem, so there's no traditional u sub that you could do, which leads to the arctangent, and it's going to be 1 over a multiplied in front, and I'll kind of show you how this turns out. So first example is going to just be finding the integral of this. Now a is going to be a squared constant, so even though 8 is not a square of anything, we're going to treat it like it is a square of something. So we're going to consider that a squared is equal to 8. So therefore a has to be the square root of 8. And we can simplify the square root of 8 as 2 square root of 2. So that's what we're going to have for a. And then I'm subtracting by a squared variable, so I'm subtracting by x squared. So now it's just a matter of plugging it into the formula, and my integral is going to equal arcsine, and it's going to be the arcsine of u over a. In this case, u is a variable, so it's going to be x over a being 2 square root of 2. Down over here, and plus c, and that's our answer. For number 2, it's a constant squared plus a variable squared, so it follows the arctangent pattern. So similarly, we have a squared equal to 27. So if you take the square root of that, it's square root of 27. And hopefully you can recognize this quickly, that this simplifies as 3 square root of 3. And you can just jump right into the answer being 1 over a, so it's going to be 1 over 3 radical 3. And then arctangent of the variable over a, so in this case t over 3 square root of 3 plus c. I'm going to sneak that in there, kind of run out of room here. Now it is I guess noteworthy to know that sometimes in the back of the book, or depending on how the answer is written, it could be that they use a tangent inverse like this, and this means the exact same thing. So if you write out arctangent, or if you have tangent inverse, it means the exact same thing. That problem for this section of this integral. And just by quickly kind of comparing it to the arcsine, it does match up, because I said the arcsine follows a pattern where it's a constant squared minus a variable squared with no other variable in it, and I can see that I have this x in it. So it's not going to match the pattern initially. So I'm going to do something, a little integration technique, which is going to be to split up the integral. And what I mean by split up the integral is I have 2 terms in the numerator. I'm going to write this out twice, so it's going to be x over the square root of 4 minus x squared. So I'm going to split this up, and then plus the integral of negative 3 and the square root of 4 minus x squared dx. Now I could have maybe subtracted by 3, but I'm just going to consider this negative 3 as a constant. So what all I did was is I have 2 terms in the numerator, is I split up each individual term, because now I can integrate each one of these separately. This is going to require a u sub, And this one over here follows the arcsine pattern because I have a constant squared minus a variable squared. This -3 is just a constant which I can factor out in front. So this follows the arcsine. I'm just going to write this sine inverse pattern. So then it's just a matter of doing each separate integral. For this one, I'm going to let u be the inside of the integral, inside of the radical. So it's 4 minus x squared. The derivative of that is -2x dx. Don't have this extra -2, so I divide it over. And this integral turns into x and dx get replaced with -1/2 du. This is square root of u. I can factor this out with a -1/2. Square root of u in the denominator is going to be u raised to the -1/2 power du. And this becomes -1/2. I apply the power rule on this. The power rule says add the power by 1, so it's positive 1/2 over 1/2. So I get 1/2 times 2 square root of u, and then I can cancel these off. So what I have left over is the square root of u, which initially I set was 4 minus x squared, so square root of 4 minus x squared for this part. And going over here on this side, like I said, the arcsine pattern, a squared is going to be 4, so that means a is equal to square root of 4, which is 2. Again, the constant squared minus the variable squared. So I can just consider this as the integral. Just factor out this -3 and think of this as dx square root of 4 minus x squared. This -3 is a constant, I factored it out, and so this just becomes -3 arcsine of u over a, so in this case it's x over 2 plus a c. And so I can just combine this integral with what I had previously for my final answer. So it's going to be this one minus 3 arcsine of x over 2 plus c, and that's my final answer. And that is all for part 1 of 5.7.